DHMO. It's used in virtually every facility in the world. Dihydrogen monoxide is a colorless, odorless substance. It is responsible for thousands of deaths each year. Prolonged exposure to its solid form causes severe tissue damage. It can accelerate corrosion and rusting and is the major component of acid rain. It is used in nuclear power plants, and quantities of dihydrogen monoxide have been found in streams and lakes around the world. Its basis is the unstable hydroxide, the components of which are found in a number of caustic, explosive, and poisonous compounds. It has been found in excised tumors from terminal cancer patients. Governments and the United Nations have refused to ban its production. Dihydrogen monoxide is H2O, water.
In this age of million-dollar jury awards suing fast food suppliers for obesity and exaggerated warnings or claims of danger from manufacturers seeking legal protection, we begin to take these cautions, warnings, and disclaimers with a touch of skepticism or disregard. When it comes to hazardous chemicals in the workplace, words, colors, and symbols really mean something. When properly used, handled, and stored, chemicals pose minimum to no risk. Hazard communication provides valuable information about the chemicals in your workplace and presents proper procedures and practices to help ensure your protection. Not only is it your right, it is your responsibility to know what they mean. In this program, we will discuss the purpose and role of hazard communication, the different classifications of chemicals and their hazards, the two primary forms of communication, container labels and material safety data sheets, and best practices you can take to help ensure your safety and health. We come in contact with potentially hazardous chemicals every day, both on and off the job. The purpose of hazard communication is to effectively communicate in a systematic process a chemical's identity, its physical and health hazards, and any special precautions required for its safe use, transportation, and storage. Why is this information important to you? It provides you with the information necessary in order to properly handle, use, and dispose of hazardous chemicals safely. The goal is to ensure your safety and health. The Hazard Communication Standard requires producers and importers to evaluate the chemicals they produce to determine if any hazards exist. The chemicals are classified by their hazard category. The two primary means required for communicating this information to customers and end users are container labels and material safety data sheets. The manufacturer or importer is responsible for the accuracy of the information. With over 650,000 chemicals designated as hazardous, each has been classified into a category based on their respective safety, health, and environmental hazards. The Department of Transportation has broken these into 9 hazard classifications. The Global Harmonized System has criteria for classifying chemicals into 24 hazardous categories. It is important you be familiar with the chemical properties and characteristics for the substances you use and fully understand their specific hazards. Though there are over 500,000 chemicals classified as hazardous, you probably deal with a much smaller number in the performance of your job. Substances are described by the physical characteristics and chemical properties. Is it a solid, liquid, or gas? What is its flash point, the temperature at which a liquid gives off enough vapors to form an ignitable mixture? Is its vapor density lighter or heavier than air? Is the chemical a corrosive material, a highly reactive substance that causes damage to living tissue, or is it toxic, poisonous? Knowing this information and the potential consequences enables you to make proper decisions to ensure your safety. When handled and used properly, chemicals pose a controlled risk in the work environment. The odds of negative consequences occurring increase when proper precautions and best practices are not followed. Different chemicals present different hazards. In addition to physical hazards, chemicals can affect your health with contact or exposure, causing irritations, acute and chronic illnesses, respiratory problems, organ damage, cancer, and even death. The 4 primary routes of entry for chemicals into the body include inhalation, injection via contact with body openings, ingestion, and absorption by the skin. Inhalation occurs when chemical vapors or fumes are breathed in through the nose or mouth, pass through the throat, into the bronchial tubes, and into the lungs. The lungs contain thousands of tiny air sacs called alveoli. The alveoli exchange oxygen for carbon dioxide in the blood. Chemicals can be passed through the thin membrane in the alveoli and into the bloodstream. Injection. Chemicals can enter your body through contact with openings such as the eyes, cuts on your hands, or other openings with splashes and spills. Ingestion occurs when the chemical comes in contact with food or beverages directly or indirectly via transfer from the hands and enter the body. Absorption. Chemicals can also enter the body when they come in contact and penetrate the skin through the pores and enter the bloodstream. By understanding the physical characteristics and properties of the chemicals you work with, you can make proper decisions and utilize best practices to ensure your safety. Remember, the two primary means for communicating this information to you are container labels and material safety data sheets. Each container of hazardous chemicals entering the work environment must be labeled or marked with the name of the chemical, appropriate hazard warnings, and the name and address of the responsible party, and the target organs affected if applicable. Any labeling system may be used as long as it meets the Hazard Communication Standard Labeling Performance requirements. There are 5 labeling systems used by most manufacturers and importers. You must be familiar with and understand the labels found in your work environment. The American National Standard Institute, ANSI, has a voluntary labeling standard that is followed by most chemical manufacturers. The ANSI label relies primarily on words. Graphics may be used for easy identification, but they may not be used to replace written words. The ANSI label also calls for the use of single-word severity assessment, danger, warning, and caution. Highly toxic materials are marked poisoned. Additional information includes precautionary measures, instructions in case of exposure, emergency treatment, instructions in case of fire or chemical spill, and instructions for handling and storage. Department of Transportation DOT placards or labels are required on all packages, transport vehicles, rail cars, and other containers transported to your site via public roadways, rail, and waterways. These placards and labels must remain on the container or transport device until it is cleaned of residue or purged of vapors. DOT diamond-shaped placards and labels use colors, numbers, words, and symbols to communicate valuable information. The background color orange represents explosive. A red background, flammable liquids or gases. Red and white, flammable solid. Yellow, oxidizer or organic peroxide. White, poison. Black and white background, corrosive. Blue, water reactive. Yellow and white, radioactive. And green, non-flammable gas. The National Fire Protection Association, NFPA, uses a 4-color diamond system with numbers and symbols. Numbers in the colored sections range from 0, least severe hazard, to 4, most severe. The color blue represents health hazard. Red is the substance's flammability hazard, and yellow, the substance's instability. The white section uses symbols to denote special hazards. There are only 2 NFPA-approved symbols. The letters OX indicates an oxidizer, a chemical which can greatly increase the rate of combustion. The letter W, with a line through it, indicates the chemical has unusual reactivity with water. The Hazardous Material Information System, HMIS, is similar to the NFPA system in that it uses colors, numbers, and symbols to indicate the chemical's hazards. The numerical ratings of 0 to 4 indicates the chemical's hazard level, with 0 being the least severe and 4 being the most severe. The blue bar represents the substance's health hazard. An asterisk next to the number indicates the chemical is a chronic hazard, with potential consequences from long-term exposure, as opposed to short-term exposure, which the number indicates. The red bar indicates the substance's flammability hazard. The yellow bar indicates the chemical's reactivity rating. How stable is the substance? The white bar uses letters to designate the type of personal protective equipment to be worn when handling the chemical. The Globally Harmonized System of Classification and Labeling of Chemicals, GHS, has been formally adopted by the United Nations. GHS establishes standardized and more detailed requirements for labels, including consistent use of pictograms, single words, danger, and warning, harmonized hazard statements, such as fatal if swallowed. Harmonized label elements are provided for each hazard category and class within the category. Container labels provide quick, instantaneous, valuable information on hazardous chemicals. Inform your supervisor immediately if any containers have damaged, unreadable, or missing labels. The Material Safety Data Sheets, MSDS, provides much further detail on the chemical. The manufacturer or importer is responsible for the accuracy of the information and must provide the customer with a copy for each chemical. All workers must have access to the MSDS for each hazardous chemical they use. The purpose of the MSDSs is to provide detailed information on each hazardous chemical at your site. Though material safety data sheets are not required to look the same or follow the same format, they all must contain the same content. Most material safety data sheets follow the ANSI recommended format or the Globally Harmonized System. With the exception of the order of the headings being reversed in sections 2 and 3, the harmonized data sheet is the same as the ANSI one. Each contains 16 sections with standardized headings. Information of importance to the worker can be found on the front of the document, such as emergency contact information, hazardous components, physical characteristics, appropriate warnings, routes of entry, symptoms of exposure, first aid and emergency procedures, personal protective equipment, and other precautions and requirements. Technical and regulatory information are contained towards the end. Why is this information important to you? By understanding the information presented on the material safety data sheets and the container labels, you have the knowledge and ability to make decisions concerning the handling, use, and storage of the chemicals you work with to ensure your safety and health. Engineering measures and safe work practices are the first option for controlling your exposure. Knowing a chemical's vapor density enables you to properly use ventilation. Knowing a chemical's flash point enables you to select the proper tools or ground equipment to prevent an ignition source. Best practices include pre-planning your activities. What are the hazards associated with the activities you will be performing? Do they create additional risks? Are extra precautions and permits required? Know what to do and how to summon emergency assistance in the event of an accidental release, fire, or exposure. Inspect all equipment and tools before each use. A frayed electrical cord could be a source of ignition. When possible, use materials that are less hazardous. Make sure all containers of hazardous materials are in good condition and properly labeled. In addition to ventilation systems, engineering controls can include monitoring devices, isolation and guarding, structural design, mechanical assistance, automation, and more. Personal protective equipment is another means of reducing your exposure to hazards. Knowing the severity of the hazard and the routes of entry into the body can assist in assessing the hazard and selecting the proper PPE. The container label and Section 8 of the MSDS also designate required PPE. Inspect all PPE before each use. Look for wear, tear, and other signs of degradation. When removing, avoid bare skin contact with contaminated gloves, clothing, and other equipment. In today's world, security should be a concern when working with or around hazardous chemicals. Make sure all gates and doors are properly secured when leaving the area. Be extra observant and report any suspicious activities or unauthorized personnel immediately to your supervisor or security office. Additional safe work practices when working with or around hazardous chemicals include good housekeeping. Good housekeeping reduces the risk of slips and falls or spilling a substance. Proper hygiene. Wash your hands after working with chemicals, especially when handling food and other items placed in the mouth. Treat all chemicals with respect. Know the location of your site's written plan and be familiar with its content. If you have questions, ask your supervisor. Chemicals are an integral and valuable part of our lives. We come in contact with them on a daily basis. When respected and handled properly, they pose minimum risk to our safety and health. Recognize and respect the hazards associated with the chemicals you use. Know their physical characteristics and chemical properties. Understand the container labels used at your site. If you have questions, ask your supervisor. Know how to access and read the material safety data sheets. Be familiar with and follow all company policies and safe work practices. Use the proper personal protective equipment when required. Plan your activities and control the risks. Knowledge is a valuable tool. Not only is it your right to know this information, it's your responsibility to use it to protect your safety and that of your co-workers.